Hello friends, every building begins with walls, and strong buildings don't happen by accident. They happen when the right choices are made early. Walls don't just support a structure, they shape the speed, cost and overall quality of the entire project. In today's fast-changing construction world, smart builders are no longer choosing materials the old way. They're choosing performance, speed and sustainability. And this shift in thinking is exactly where ShreeShakthi comes in. Established in 2014, ShreeShakthi has been focused on one clear goal: making wall construction smarter, faster and more reliable. Backed by automated technology and guided by over 4 decades of industrial expertise, ShreeShakthi manufactures AAC blocks and dry mix products that are trusted across residential, commercial and industrial projects in India. To support modern construction, we bring you a complete advanced wall solution: ShreeShakthi AAC blocks, jointing mortar, plasters, wall putty or tile adhesive. All designed to work seamlessly together as one integrated system. In the next part, we'll show you how to use each of these correctly so you get stronger walls, cleaner finishes, faster execution and long-term performance on every project. Autoclaved aerated concrete blocks, commonly known as AAC blocks, are not just an alternative to red bricks. They represent a better evolution in wall construction. Because of their size, strength and precision, AAC blocks help speed up construction by up to 30%. Their uniform surface also means 35 to 40% less plaster consumption, while the lighter weight reduces the overall requirement of steel and concrete in the structure. Beyond efficiency, AAC blocks offer excellent thermal insulation, helping maintain comfortable indoor temperatures, along with superior sound insulation that reduces external noise. They also provide fire resistance of up to 4 hours, adding an extra layer of safety to the building. Now that we understand why AAC blocks are a better choice, let's look at how they should be used correctly on site to get the best results. AAC blocks are engineered materials and they perform best when they're handled with a little care. In practice, this usually begins with proper storage, keeping the blocks on a dry, level surface and using them only when they are completely dry. This helps avoid small issues like edge damage or minor alignment variations later on. On site, adjusting the level periodically, especially after a few layers, helps maintain clean lines and accuracy. Before construction starts, a bit of advanced planning goes a long way. Defining wall thickness early, generally around 100 mm for internal walls and 150 to 200 mm for external walls, makes execution smoother. Reviewing the wall layout in advance also helps in choosing the right block sizes and reduces unnecessary cutting or wastage during construction. When it comes to bonding, AAC blocks are designed to work differently from conventional brickwork. Instead of thick cement mortar joints, they perform better with thin joint systems. This is where ShreeShakthi jointing mortar comes in. A factory-prepared mix with controlled proportions, typically applied in a thin layer of about 3 mm. Rather than soaking the blocks, a light surface moistening is usually sufficient. The jointing mortar must be applied evenly using a notched trowel, ensuring uniform bonding strength across the wall. To maintain accuracy and strength, the base layer should first be leveled using conventional cement sand mortar. Construction should always begin with corner blocks, keeping all blocks at the same height and checking alignment regularly using a level instrument. While laying, ensure a proper bonding pattern with at least 1/3 block overlap or a minimum of 100 mm, which helps distribute loads evenly. One major advantage of AAC blocks is that curing is not required, unlike traditional bricks. This saves both time and water and allows construction to move forward more efficiently. For added stability and to manage structural stresses such as movement, tension and shrinkage, the use of bed joint reinforcement or nominal bond beams is recommended. Typically, 5 to 6 layers or about 12 mm of bond beam can be provided using 6 mm stirrups and 8 mm TMT bars, properly anchored into nearby columns. The bond beam height should be more than 80 mm and filled with M15 concrete. Where required, galvanized steel wire mesh may also be used. In areas with doors, windows or large openings, precast lintels should be used. For openings between 1 to 2 meters, lintels should rest on the blockwork with a minimum bearing of 200 mm on each side to ensure proper load transfer. At the top and side junctions of walls, a small gap of 10 to 20 mm should be left to accommodate structural movement. This gap can initially be left empty and later filled with polyurethane foam or a loose cement sand mix, helping prevent load transfer from slabs to walls due to deformation. Before plastering, special attention should be given to joints between dissimilar materials. Chicken mesh or fiber mesh should be applied at beam column junctions, door and window corners, and PEB interfaces to minimize cracking and improve durability. For services like electrical conduits and plumbing, chiseling should be done carefully using an electric router or suitable cutting tool. While creating wall chases, cutting machines are recommended instead of hammering, as hammering can create unnecessary stress on AAC block walls and may lead to surface cracks. The depth of the cut should not exceed 1/3 of the wall thickness, and blocks should never be cut fully from the back, especially in thinner walls, as this can weaken the structure and affect long-term performance. When fixing fixtures, only plastic or nylon expansion anchors should be used. Metal, wood or glass anchors are not recommended. Drilling should always be done in drill mode, not hammer mode, to avoid damaging the block structure. Finally, for long walls exceeding 6 meters, movement or control joints of about 10 mm width should be provided, starting around 3 meters from the corner. These joints should be filled with resilient material and properly sealed to prevent water ingress, ensuring long-term stability. Once the AAC blockwork is completed, plastering becomes the next key stage in finishing the walls. AAC blocks offer a clear advantage here, as their dimensional accuracy and uniform surface allow plastering to be more controlled and efficient compared to traditional brickwork. Plastering should be carried out only after the walls are completely dry. Unlike conventional bricks, AAC blocks do not require curing, which helps save water and allows work to progress without unnecessary delays. Before plastering, the surface should be clean and free from dust or loose particles. Light surface moistening may be done if required, but soaking the blocks is not necessary. For internal walls, gypsum plaster is often preferred due to its smooth finish and minimal shrinkage. Where cement sand plaster is used, a thickness of around 10 to 12 mm generally works well. For external walls, cement sand plaster is applied in layers, with the base coat typically around 15 mm and a finishing coat of 5 to 10 mm, along with suitable waterproofing additives to improve durability. At junctions where AAC blocks meet other materials such as beams or columns, applying wire mesh or fiber mesh before plastering helps reduce cracking and improves long-term performance. Using excessive plaster thickness, applying plaster on damp surfaces, or rushing the drying process can affect finish quality. When done correctly, plastering on AAC block walls results in smoother surfaces, reduced material consumption, and a durable base for further finishes. Once plastering is completed and the surface is fully dry, wall putty is applied as the final preparation before painting. On AAC block walls, wall putty application helps achieve a smoother finish, reduces paint consumption, and improves long-term paint performance. Before application, the surface should be clean, dry, and free from dust or loose particles. Wall putty performs best when applied in thin, even coats. The first coat fills fine pores and minor surface variations, while the second coat smoothens the surface and prepares it for painting. Wall putty is mixed to a smooth consistency and applied using a steel trowel with uniform pressure. Light sanding after the first coat helps improve surface uniformity, and the second coat completes the finish. Allowing sufficient drying time between coats is important for proper adhesion. Applying putty on damp surfaces, using excessive thickness, or painting before the putty has fully dried can affect finish quality and paint durability. When applied correctly, wall putty enhances surface smoothness, improves paint life, and delivers a clean, long-lasting finish. Once the surfaces are properly prepared, tile fixing becomes the next important stage, both on walls and floors. Using a tile adhesive instead of traditional cement sand mortar helps achieve stronger bonding, better alignment, and long-term performance. Tile adhesive is designed for thin bed application, which allows uniform coverage with less material and improves overall efficiency. On walls, tile adhesive helps hold tiles firmly in place and reduces the chances of slippage during installation, resulting in a cleaner and more accurate finish. On floors, it supports even load distribution across the surface, which helps minimize issues such as hollow sounds or tile failure over time. When applied on clean, level, and dry surfaces, tile adhesive also speeds up installation and delivers consistent results. Application is typically carried out using a notched trowel to ensure even spreading. During fixing, tiles are gently pressed into place to ensure full contact with the adhesive, and alignment is checked regularly using a level or tile spacers to maintain uniform joints. Light tapping with a rubber mallet may be used where required to achieve proper bedding. For best results, tile adhesive performs well when applied in thin, even layers and within its recommended working time. Applying it on dusty or wet surfaces, using excessive thickness, or fixing tiles after the adhesive has started setting can affect bonding performance. When used correctly, tile adhesive provides a clean finish, strong adhesion, and long-lasting tile performance on both AAC block walls and floors. When the right wall material is combined with the right application system, construction becomes faster, more efficient, and more reliable. If you're planning a residential, commercial, or industrial project and are looking for a wall system that delivers performance, reliability, and long-term value, connect with ShreeShakthi. Build with clarity, build with confidence, build smarter with ShreeShakthi.